Let's just jump right into this explainer because we need to fundamentally shift how we think about AI product economics. Honestly, if you still think pricing AI is just about, counting tokens, you're already way behind the curve. Today, we're not treating pricing as some boring afterthought for the finance team. Nope, we're looking at it as a core system design control mechanism. It is literally the most powerful tool you have to keep your AI product alive.
Here's the roadmap for our masterclass. We'll start with the SaaS pricing trap, break down the 7 layers of hidden AI costs, explore 4 pricing models that actually work, look at the brutal trade-off between stability and scale, and wrap it all up with a solid summary.
All right, part 1, the SaaS pricing trap. We're going to see exactly why zero marginal cost is just a total myth in the AI world.
Check out the massive contrast here between a static machine and a living, breathing AI system. Think of traditional SaaS, like building a highway. Once the pavement is down, letting one more car drive on it costs you basically nothing, right? It's completely deterministic. You can throw around words like unlimited usage because your marginal costs just flatten out. But AI? AI is way more like hiring a fleet of private chauffeurs. The system isn't just executing static code, it's reasoning. And reasoning takes serious effort every single time. The costs are highly variable, totally unbounded, and they scale dynamically based on exactly how your users behave.
And this brings us to a pretty harsh reality. Look, in traditional software, high engagement is a massive win, right? Always. But in the AI world, if you're popping champagne over high engagement without having cost constraints in place, you're basically celebrating the destruction of your own profit margins. Why? Because usage actually correlates with cost volatility. Imagine running an all-you-can-eat buffet, but your food costs dynamically multiply depending on how complicated each customer's special request is. Some people just want a simple salad, but others are asking for massive, complex, multi-course meals that completely stress-test the physics of your kitchen. You simply cannot price them both the same way.
Because of all this volatility, everybody naturally fixates on token costs. I mean, they're right there, highly visible on your dashboard. But honestly, that's like obsessing over the price of gas while completely ignoring the cost of buying the car, paying the insurance, and replacing the engine. Like the side says, tokens are rarely what actually kills your business. It's everything wrapped around them.
Which leads us to part 2, the 7 layers of AI cost. Let's stack up all these hidden economics.
Think of these first 3 layers like a snowball rolling down a hill, just picking up speed. Step 1 is data preparation. Your knowledge base constantly needs cleaning and updating, which costs money whether users are querying it or not. Step 2 is retrieval. Imagine going up to a librarian and asking for one specific quote, and instead they just dump 20 heavy books right onto your desk. That is sloppy retrieval. And what happens? It silently inflates step 3, context construction. By pulling way too much data, you bloat the prompt. So you're literally bleeding money on every single query before the AI model even starts to type out a response.
Then we hit the execution layers. Step 4 is model execution. Now, a huge mistake here is lazy routing, like sending every single simple request straight to your absolute heaviest, most expensive model. It's basically like using an 18-wheeler truck to deliver a single slice of pizza. Yeah, it gets the job done, but it totally wrecks your unit economics. And then step 5, orchestration and retries. A user clicks a button, looks super simple to them, right? But behind the scenes, that one click can explode into 5 or 10 hidden model calls, safety checks, and background retries that instantly double or triple your costs without the user ever knowing.
Finally, we get to the system pressure layers. Step 6 is concurrency. 10 users spreading their queries out over an hour? Super cheap. But those same 10 users hitting the system in the exact same millisecond? Now you have a problem. That forces you to over-provision expensive server capacity, totally destroying any average cost calculations you made. It's like building extra lanes just for rush hour traffic. And step 7 is evaluation and guardrails. If you're building an enterprise-grade tool, you are paying for constant safety monitoring and quality checks. You gotta be the safety inspectors, right?
So here is the absolute crucial point to take away. These AI costs, they don't just add up, they multiply. A bloated prompt from bad retrieval forces you to use a heavier model, which then triggers more retries, which spikes your concurrency costs. The costs just spiral without any single decision looking obviously wrong in isolation. Your pricing model literally has to absorb this incredible level of uncertainty.
Let's move on to part 3, 4 AI pricing models. We're talking about frameworks that actually survive real-world usage. So we basically have 4 primary models to navigate this crazy landscape. First up is usage-based, kind of like the OpenAI API. It's brutally honest. You just pay for every single token. But for an average consumer, that feels a bit like watching a ticking taximeter, which totally kills the desire to explore the tool. Second is the hybrid model. Think Notion AI. Users pay a base subscription to play around, but if they go crazy, heavy users trigger overages. It's a great safety buffer for the business. Third, we have outcome-based, like enterprise copilots, where you're just paying for a resolved ticket. But heads up, you can only pull this off if your system is incredibly bulletproof reliable. Finally, capacity-based, like SF Compute. This is where you pay upfront to reserve throughput. It's essentially buying a VIP table at a crowded restaurant, so you know for sure a seat is there during the dinner rush, whether you sit in it or not. The fatal mistake here? Picking a pricing model just because it looks flashy on a pitch deck or, because some hot competitor is doing it. Please don't do that. You have to pick the model that acts as a strict control mechanism for the specific way your system tends to fail. Always choose based on your system's actual physics, not whatever the current industry fashion is. Okay, into part 4, stability versus scale. This is the central strategic tension you're going to face.
Let's define these terms clearly. Stability requires absolute predictability. We're talking about avoiding hallucinations, maintaining top-tier quality, and failing gracefully when things go wrong. Think of stability like building a heavily armored bank vault. It is ridiculously expensive to build and maintain. It demands the heaviest models, the tightest guardrails, and constant background retries. It's not a feature, it's a massive budget allocation. Scale, on the flip side, demands raw throughput. It is all about handling massive bursts of simultaneous demand. If stability is a bank vault, scale is a Formula One race car. It rewards doing things incredibly fast, really cheap, and with practically zero overhead. But naturally, if you're pushing things through that quickly and cheaply, you are significantly increasing the probability of getting unpredictable, unstable answers. And here's the kicker. You simply cannot have a Formula One car that is also a heavily armored bank vault. And honestly, this exact tension is why your premium pricing tiers shouldn't just offer, quote-unquote, more usage. No, they need to explicitly fund those super expensive safety guardrails required for enterprise-grade stability. When your customer decides to upgrade, they aren't just buying a bucket of extra tokens. They are paying for that armored vault. They're funding a stability budget, so your system can actually afford to think a little longer, double-check its own work, and deliver a perfectly reliable answer. Which brings us to part 5, our masterclass summary. Let's synthesize this whole AI P&L playbook.
Seriously, if you only take one single idea away from this entire explainer, please let it be this rule right here. Price for your worst reasonable day, not your average day. Why? Because AI systems fail spectacularly on the absolute edges during peak demand bursts. If your pricing only works out when users behave perfectly on a quiet Tuesday afternoon, your margins are going to completely vanish the second a complex, chaotic use case hits you right in the middle of rush hour.
To wrap up our playbook, first, remember that pricing in AI is a system design choice. It's the absolute strongest control mechanism you have to shape how users interact with what you've built. Second, expect your gross margins to actually plateau as you scale up, mostly because you're going to have to heavily invest in that necessary stability and all those guardrails. And third, you have got to enforce constraints. Being generous with unlimited pricing just trains your users to behave expensively. Adding a little bit of friction is entirely necessary for your product to survive in the real world.
Pricing AI is practically an entirely new discipline, and mastering it means mastering this wild intersection between human behavior and system physics. So I'll leave you with this question. Is your current pricing model actually paying for your product's survival, or is it secretly funding its collapse? If you found this tutorial valuable and want to really master the mechanics of building and scaling AI products, take action on this final thought. Subscribe to AI Product Management Playbook by Deepak Dio on LinkedIn. Thanks so much for hanging out with me for this deep dive, and I'll catch you in the next explainer.